All right. So again, I'm at the 6.1 Intro to Circle Equations Delta Math. All right, we're going to be doing a bunch of these together. So, circles. There's a lot of things in math that revolve around circles. When we get to Unit 8, you'll see the unit circle. All right, that deals a lot with trig. Circles, in this case, you'll see a lot with the equations of circles, which that will be on the EOC. All right. You'll also see a lot of stuff with their segments and angles that are formed within circles. So that's essentially what most of this unit is all about. All right. Now, we're going to start by deriving the equation of a circle, or how we can find an equation of a circle or derive it. So go to the very first problem. So it's development of a circle equation guided. It should be the very first one. So you should see this. So it should be the exact same thing as me. So everyone should be on Delta Math. 6.1 intro, very first one. All right, so what it says here is that this circle has a center point O, which is at 3, 5. And a point on the circle is letter A, which is at 11, 10. Now, they place a random point within the circle B to be 11, 5. And they want us to write a subtraction expression to find the length of OB and AB. So let's think about this logically. All right. Here's O, here's A. I want to find the length of AB and the length of OB. So, look at the numbers specifically of the points. All right. Typically, if I just had you guys do it like we did with the warm-up, what would you just do? You would count them. All right. Well, we can also use the parts of the points to subtract and get that same distance. All right. Now, is this horizontal or vertical? Is this horizontal? So OB is horizontal. So if we're thinking graph-wise, what values of a graph are strictly horizontal, x's or y's? X's. So what two values are we going to subtract? 3 and 11. So we're going to do 11 minus 3 because we want positive numbers. What about AB? So this is vertical, right? So what values do you think we want to subtract? 10 and 5. So what should we get for this one? And this one? Now, if we actually count them, is that what we get? So take a minute, count both these lengths. See if you get 8 and 5. So you should get 8 and 5. So first thing we're going to do is type in those two expressions that we just wrote out. So I'm going to do 11 minus 3 and 10 minus 5. Which gives us the lengths of 8 and 5. All right, everybody following so far? All right, now, the next thing they want us to do is plug these two values into the Pythagorean theorem. So, if this is the length of 8 and 5, we're going to try to find the length of OA. Let's call that x. All right, so we're going to use the Pythagorean theorem, like we just did, to find that length. So what they asked us to do is to first off, just plug it into the Pythagorean theorem. So what am I going to put here? 8. What am I going to put here? 5. So far, and I'm just going to write off to the side, I have 8 squared plus 5 squared is equal to OA squared. All right. Now let's find the exact value of OA. So let's work together and solve this. What's 8 squared? 64. What's 5 squared? 25. Still equal to OA squared. What's 64 plus 25? 89. Equals OA squared. How do I get OA by itself? Square root both sides. All right. So the square root of 89 is equal to OA. And we're just going to leave it like that because we know they're not perfect squares. All right. So literally type in for your answer of OA the square root of 89. All right. Has everyone got that inputted up to this point? All right. Now, why they make us do this? Because doing it with numbers first puts it more into perspective when we take the numbers away. All right. So we're essentially going to be doing the exact same process, except this time we don't know the exact point that's on the circle, which is now XY. So C is now the exact point on the circle XY, but the center is the same. And the hypotenuse of our triangle will be the same. Because technically, what is this hypotenuse called in reference to the circle? It's the circle's what? Radius. All right. So, that being said, all right, we can still develop a right triangle and use Pythagorean theorem again. So, we're now going to write subtraction expressions for OD and CD. So, if you think back to how we did AB and OB, all right, what do we essentially do to get these distances if we can't count? You subtract them. So, for the horizontal, what am I subtracting? The x or y values? The x's. All right. So this would be x minus what? 3, which is this x value. Typically, you want to put the variable first. All right. What about here? X minus x. Y minus 5. It's vertical, so we're dealing with y values. All right. So that's what we're going to type in for the next two. So OD is x minus 3. CD is y minus 5. Now there is a method to this madness, and you'll see it in just a second. So now we're going to plug that into the Pythagorean theorem. All right, so just like we did here, we're going to do the same thing for the two values that we just came up with. And we already know what the radius or OA is, or OC, whatever. It's the same radius. So I have x minus 3 squared plus y minus 5 squared. I'm just plugging in my subtraction expressions into here. And it's going to equal the square root of 89 all squared. All right, does everyone understand why I plugged them in and squared them? It's just Pythagorean theorem, except instead of numbers, since we still have a variable, we're just plugging in these expressions for A and B. Because remember, Pythagorean theorem, A squared plus B squared is equal to C squared. All right, so that's what you're going to type in here, x minus 3 and y minus 5. Now, to finish it up, we just need to do some simplification. And there's only one place that I need to simplify. Can anyone identify it for me? There's one place where I can simplify. Where? So in this equation right here, what's the one place I can simplify? The what? So not the y minus 5. So in reality, the whole left side of the equation we can't touch. All right, we don't want to touch it. But can't I simplify this? Isn't that just going to give me a number? So if I'm doing the square root of 89 squared, what happens to the square root of the square? It cancels each other out. So I'm left with what on the right side? 89. So my circle equation is x minus 3 squared plus y minus 5 squared. That's equal to 89. So that's you're going to type in to your final answer. Make sure you put the parentheses. So x minus 3 squared plus y minus 5 squared is equal to 89. So this actually describes, this equation that we just came up with is actually the equation of the circle. So let's say that we graph this in Desmos. So you don't need to do this, but I'm going to do it. All right. So I'm going to switch over to Desmos real quick. If I type in that equation that we just came up with, we should get the exact same circle. So I have x minus 3 squared plus y minus 5 squared is equal to 89. And I did, in fact, get that circle. All right, if I zoom in a little bit, the center, let's say I plot that point, is 3, 5. That is definitely the center. And the radius will end up being about 9 and some change. All right, which if we zoomed in and counted, that is exactly what it is. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, and then there's a little bit left over. So it all worked out. Now, here's my question to you guys. Why does that equation make sense? So if I go back and look at the original circle, all right, actually, let's look at this one. So the radius is the square root of 89, and the center is 3, 5. What about this equation can relate back to those two pieces? What do you notice? What's the connection? So the center is 3, 5. Do you guys see a 3 and a 5 anywhere in the equation? Yeah. Not true, the x value is 3? Y value is 5? Only thing that happened is what? The sign flipped. All right. Now, this is the square root of 89. You see an 89 or square root of 89 anywhere in the equation? Yeah, right here. However, this is the radius squared. Now, we're going to try another one and see if it holds up in court, what we think is true. All right. Har. So, let's go to the next one. So go to the next one down. And we're going to essentially do the same process. So what I want you to do is use that same process that we just did and get the first two. So write these subtraction expressions for these two. And then find the length of those two sides. So I'll get you started on the subtraction expression. All right. So this time, our center is 2, 3. Point on the circle is negative 6, 8. So this right here will be my what? The hypotenuse of the triangle, the radius of the circle. All right. So how can I write a subtraction expression for OB? You can do 2 minus negative 6. That's fine. We do want a positive number. What about here? 8 minus 3. All right. Now, that's what we're going to type in down here. So OB is 2 minus -6. Make sure you put the -6 in parentheses. And then 8 minus 3. So that means that OB is what in length? 8 units. Oops. So if you counted from here to here, how many units? Is that 8? Do you have 8 units right here if you counted? Yeah, you should. What about AB? 5. So if you count it right here, you should definitely have 5 units. All right, so we're just finding those distances. Now, we're going to do the same thing and plug in for the Pythagorean theorem. All right, so what goes here? What goes to the other one? Back. Now, does that give you a little sense of deja vu? Isn't that pretty much the same numbers that we had for the last one? Yeah, so what should our answer be when we solve? Not 89, but square roots of 89. So we don't even need to solve that one. We already did the Pythagorean theorem in the previous question. So everyone got up to here. So square root of 89 is the answer to OA. It's the same one as the previous problem. And that's just coincidence. Now, back over here. Now they took away our numbers. We're left with the point on the circle being x, y. So we got to use the points to write out subtraction expressions for the distances. So for my horizontal, what values am I using, x or y? X. So it'll be x and then what? Minus 2, because 2 is my x value, my center. What about here? What values am I using, x or y? Y. So we will have y and then minus 3, because 3 is the x, 3 is the y value of my center. So that's what they're going to ask us. So x minus 2, y minus 3. Now, just like we did with the last one, we're going to take those values, plug them back into the Pythagorean theorem, including the radius that we already found in the previous question. So this would be x minus 2 squared plus y minus 3 squared, and it's equal to square root of 89 all squared. So all we did is just plug it into the Pythagorean theorem again. So that's what you're going to type in here. X minus 2, y minus 3. So what's the only thing that I can simplify in that equation? Right. The square over here. So this would be x minus 2 squared plus y minus 3 squared is equal to square and square cancel out, 89. And that's your equation of the circle. So x minus 2 squared plus y minus 3 squared is equal to 89. Now, let's see if the observations that we originally had held up. All right. Is it true that the left side of the equation contains values that are in my center points of the circle? So my center point is 2, 3. Is there a 2 and 3 here? Yeah, except what happened? The sign flipped. Now, my radius, is it not true that it was the square of the radius? Yes. All right. So, here is typically the formula for the circle equation. The circle equation will always be x minus h squared plus y minus k squared is equal to r squared, where your center is equal to the point hk and your radius is equal to r. So this is actually the formula for any circle equation. All right, you take whatever the center point is, flip the signs, put it next to x and y respectively, and square it. Then square it said equal to the radius squared. Pretty easy, right? So in other words, if I give you any circle and I give you the center point and the radius, you should be able to find the equation of the circle. On the flip side, if I give you the equation, you should be able to identify the center and the radius. All right? So let's actually try some more with that. So where does that equation of the circle come from? It actually comes from the Pythagorean theorem. That's why I had you guys do Pythagorean theorem for warm-up this morning, because you would see it again with the circle equation. All right? So let's go to the next one, that delta math. So find the center and the radius from the equation. So based off of what I just told you about the circle equation, all right, how can we identify what the center point is? So here's the formula, and then what each means. How can I identify what the center point is? What? Close. You had it right the first time. 15 and negative 8. So remember, flip the signs. So if this is negative, that means this is positive. If this is positive, that means this is negative. So your center is the point 15, negative 8. Now, what about the radius? 12. How do you know it's 12 and not 144?
Because it's squared.
Right, because in the formula it's r squared. So to get the actual radius, you have to square root whatever it's equal to. And that's 12. So your radius is 12. Any questions on identifying that? All right. Now let's try our hand at graphing some circles. So, graphing circles. We're going to start with this equation, which I'm just going to rewrite over here. We're going to be moving it around a lot. So x plus 7 squared plus y plus 3 squared is equal to 9. Now, whenever you graph a circle, the very first thing you should do is look at the equation and identify the center point and the radius. So, what do you guys think my center is going to be? Negative 7, negative 3. Since these are both positive, and remember it's negative originally in the formula, we flip the signs. So negative 7, negative 3. What do you guys think my radius is?
3.
3. Because we got to take the square root of 9. So that'll be 3. So now that we got that, we now have enough information to graph this. So the first thing we're going to do is we're going to move our center point to be my center point. So -7, -3. So I'm going to move this all the way over to -7, -3. So right here. Now, your radius. How many units away from the center should this point be if my radius is 3? It should be 3 units away. So count. Take the outside point, or the point that's on the circle, and pull it so that's 3 units away from the center point. So that's 2, and that's 3. And there you have a graph of a circle. Pretty easy, right? The hard part's identifying the things. But once you do, it's an easy graph. All right, let's try one more together. So go to the next one. All right, so I'm going to change this equation. So this is x minus 3 squared, y plus 2 squared, equal to 36. So first things first, we need to identify my information. So what's my center point? 3, -2. Good. What's my radius? 6. Remember, it's r squared in the equation, but we just want r. We got to square root that 36. So once again, I'm going to take that information. I'm going to plot my center point first. I'm going to go move the center to 3, -2. So right here. How far away from the center point does my outside point need to be? 6 away. So it's already 1 away, 2, 3, 4, 5, 6. And there's your circle. The information's still on the board. Any questions on how to graph the circles? So what I want you guys to do is I'm going to give you guys about 7 minutes. Those last 4 problems, which is that last section, just what we've just been doing, do it on your own. All you're doing is just identifying the center of the radius, graphing the circle. That's it. So literally what we've just been doing. So I'm going to set the timer. It'll be nice. I'll give you 8 minutes. Go ahead and knock those 4 out. So that will be 100 on that delta map if you've been following along. That's really good. Square root, not square. Do this first. For this one, would they, since I vote a positive, would they So once you finish, close your Chromebook so I know you're done. And then you can just chill for a minute. So it'd be positive 30. And then the raise just take the square root of whatever it's equal. Well, think about it, 19 minus 81. So we have to assume that it's 40. Nothing. Yes. No, I think that for different. Wait, like, do they really not get it anymore? Yeah.
Yes. We're getting into the best business. It's okay. I'll find a way to make.
All right, show of hands, who's done?
Three different people.
So it's basically how far away from the point that. So raise is 1, I think you should be going. Units quicker. So you can leave it just it's square root of 3. So just take that point. So, oh. So it's basically just flip this. Yep, so if it's like, so see where I wrote like minus h minus k, that's the original formula. So the minuses are equals of this segment. So that's why it's really positive. So plus it's negative. All right, so pretty much all of you are done or close to it. So we're gonna move on. So you can close your Chromebooks. You don't need it anymore. Go ahead and open up to the first page of your packets. This should be pretty quick. All right. Shh, 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 shh. So this we can go through this fairly quickly because it's really just a reiteration of what we just learned. All right, but it goes a little bit more in depth, and it'll just actually give you guys something where you're actually writing it down. All right, so let's look at this. Now, if we're looking at this circle where our center is the origin, so this is my center. What is true about any point that I can draw on this circle? So they have a point here. What if I drew a point here, here? It'll go to the center points. So like if I drew these lines, what would be true about all of those lines? They would be what? They'll be the same. Why? Well, it's not that, but think about it in terms of a circle. What would that segment be in a circle? Right, because that's the radius. Good. So these are all radii. And the radius of a circle is always consistent. So if you drew a segment from the center to any point on the circle, you will always have the same length as long as it's the same circle. All right. So what is true about every point that lies on this circle? Well, it means that it is the same distance from the center. And again, it's because it's a radius. So algebraically, we're going to show that 6, 8 must lie on the circle. Before we can even do that, we need to write out an equation. All right. So first off, they said the radius of the circle is 10. So any of these radii are going to be 10. All right. And they said the center is the origin. So what point is the origin? 0, 0. So, and I would write this up top. So remember, the equation for a circle is x minus h squared plus y minus k squared is equal to r squared, where your center is hk and your radius is r. So knowing that, let's actually write the equation that will make this circle. So it's really just a plug and chug. So what am I going to plug in for both h and k? What's my center of the circle? 0 and 0. So this would be x minus 0 squared plus y minus 0 squared. Yeah. Now, it said the radius is 10. So what do I have to do that 10? Square it. So if I clean this up a little bit, what's x minus 0? Anything minus 0 is always itself. So this would be x squared plus y squared is equal to what? 100. So this right here is my equation of a circle that describes this circle. So they said they want us to show algebraically that the point 6, 8 has to lie on this circle. How can I use that equation to figure it out? So here's my question. What is in the equation that the point also has? An x and a y. So if this has an x and a y, this has an x and a y, what's your gut feeling you need to do? Plug it in. Now, How will you know? So this will have 6 squared plus 8 squared. How will we know if it's truly a point on the circle? What's going to happen? What needs to happen to know that 6, 8 is a point on the circle? It should equal 100 on both sides. So in other words, if we evaluate 6 squared plus 8 squared and it's not 100, then it's not a point on the circle. But if it is a point on the circle. So let's evaluate. Crap. What's 6 squared? 36. What's 8 squared? 64. And again, we're trying to make it equal 100. What is 36 plus 64? 100. So 100 equals 100. So is 6, 8 a point on the circle? Yes. So 6, 8 is on the circle. So these should be some of the easiest questions you ever get. If they give you the equation of a circle and they ask you if a point is on said circle, you just plug in those points in for x and y, evaluate the left side, make sure it equals the right side. If it does, it is a point on the circle. If it doesn't, it's not a point. So do what we just did using that same equation of a circle and figure out if 7, 7 lies on it. So go ahead, try it on your own. So doing what we just did, using that same equation of a circle, figure out if 7, 7 lies on the circle. Uh-huh. Oh, the top one? So everyone should be trying letter C. Using that same equation that we just came up with. So x squared plus y squared equals 100. See if 7, 7 lies on the circle. Did you get it, Anna, or did I move down too quick? Okay. So see if 7, 7 lies on the circle. So we're using the same method that we just did for the previous. Same equation of the circle too. All right, you guys ready? Does 7, 7 lie on the circle, yes or no? No. So if I plug in the 7s in for x squared and y squared, so I have 7 squared plus 7 squared should equal 100. Well, what's 7 squared? 49. 49 plus 49 is 98. Is it true that 98 equals 100? Nope. So it's not on the circle. All right. Now, it asks us to rewrite the equation involving the triangle and the point above. It's just that same equation that we came up with. X squared plus y squared is equal to 100. Don't even have to do the work for that because we already did it. Kind of jumped the gun, but we did that in the delta math, so it's okay. So, when equations are centered at the origin, so again, the center is 0, 0. Typically, your equation is x squared plus y squared is equal to r squared. Now, there's no problem with just continuing to use this one up here. Oops. So there's no problem with continuing to use the big formula that I told you for all circle equations. Just note that when you plug in 0 and 0 for here, you'll end up with just x squared, y squared. So it doesn't really matter. So, this next exercise said the point 74 lies on the circle centered at the origin. And we first want to write the equation of the circle and state the radius. So, let's use what we know. All right. So, it's centered at the origin. So, that means it's centered at what point? 0, 0. So, if I plug it into my equation of a circle, I got x minus 0 squared plus x minus, oops, not x, y minus 0 squared is equal to r squared. Because we don't know what the radius is yet. So remember, if you have minus zeros, that means just x squared plus y squared is equal to r squared. Now, they flat out told us that 7,4 lies on the circle. So how can I use that to solve for r squared? What can I do? I can plug it in for x and y. So I can do 7 squared plus 4 squared is equal to r squared. What's 7 squared? 49 plus 4 squared? 16 is equal to r squared. What's 49 plus 16? It'll be 65. So 65 is equal to r squared. Now, if you were just trying to find the equation of the circle, you can stop there because we can just take that 65 and plug it back in for r squared. So our equation of the circle is x squared plus y squared is equal to 65. But what did it also ask us to do? State the radius. So how do I find the radius from here? So go back to r squared. Square root it. So your radius, we're just going to leave it as the square root of 65. So this is your equation of a circle. This is your radius. Everyone follow on how I did that. I find that most people get equations of a circle because a lot of it's just Pythagorean theorem. It's a really simple formula to remember. Now, will the point negative 8, 1 be on the circle? So how do I find it? Plug them in for x and y. See if it equals what? 65. So I have negative 8 squared. Make sure you put the negative 8 in parentheses, especially if you're putting it in your calculator. Plus 1 squared is equal to 65. What's negative 8 squared? 64. What's 1 squared? Is it true that 64 plus 1 will equal 65? Yes. So is the point on the circle? Yep, it is. Now again, that's if it's centered at the origin, but we already know that that's not true. Now, they're talking about distance formula. Screw the distance formula. All right? Distance formula is a pain in the butt. Unless you're going to be doing a lot of upper level math in your life, you don't really need it. All right? If they're asking you for the distance, my go-to, Pythagorean theorem. So if they ever ask you for the distance between 2 points, use Pythagorean theorem just like we did in the warm-up. Graph the 2 points, make a right triangle, and then plug it into a squared plus b squared is equal to c squared. So just like we did with the delta math we did together, just like we did with the warm-up, that's how you want to go about distance between 2 points. All right? At least in your young math years. Now, me personally, when I was in school, I had a no distance formula, but that's because I was doing things like calculus where you kind of need it. All right? But you guys, I don't think will be in calculus. All right? God bless you if you do. I'm saying that most of you probably won't go into a profession or want to go into a profession that you have to do calculus. If you do, again, God bless you. I can help you as much as you want, but it's a whole different monster. All right. So Now, we're going to consider the circle where the center is at 4, 2 and has a radius of 5. So we're going to kind of skip letter A, all right, because I'm more focused on B. So we're going to skip letter A, come back to it. We're going to do B first. Because, doesn't this look familiar to you guys? What does this look like? The delta math we just did. Why do you think I just did that with you guys? Uh-huh. All right, so let's say that we drew that right triangle. So this point is going to be X and 2. All right. We know it's on the same Y value as the center. We just don't know what the X value is. So it's a right triangle. So if I wanted to find the distance between my center, let's call it C, and this, it's called this point A and this point B. So if I want to find the distance between C and B, how do I find it? Or how do I write an expression to describe it? X minus 4, good. Just subtracting the horizontal values. What about here? Y minus 2, vertical values. So, if I plug it back into the Pythagorean theorem, I get x minus 4 squared plus y minus 2 squared. And that's going to be equal to what? 5 squared. That's the other part of the Pythagorean theorem. It's my C. So what's the equation of the circle? So x minus 4 squared plus y minus 2 squared is equal to what? 25. Now, does that not match up with the information we were given? So, did I end up switching the signs for my center point in the equation of the circle versus what they originally gave me? Yes. Is 25 the square of 5? Is the square root of 25 5? Yes. So we did it correctly. So now, if I want to check to see if both points lie on it, again, it's just a plug and chug. Yes, they will. All right. Do I even need to do letter A, or are you guys good with that one? So, they say when the center is XC, YC, I don't like that. I'm going to say the center is HK. It's a little bit easier. So your equation of a circle when the radius is R is x minus h squared plus y minus k squared is equal to R squared. And remember, make a note for yourself. Switch the signs of HK when putting in equation or vice versa. All right, so make sure you switch the signs of HK when you're going from the equation to the point or vice versa from the point to the equation. Now, for these last couple ones, let's see if you guys can tell me what the center and the radius is. All right. So, for letter A, take a minute on your own, write down what you think the center and the radius is. Don't say it out loud, just write it down. You guys got it? Hunter, what's the center? Good. It was originally negatives, so we switched them to positives. Malachi, what's the radius? 5. Good. Square root of 25 is 5. All right. Do letter B. So write down on your own, write down the center, write down the radius. You had a whole week last week. All right, Katie, what's the center? Good. Aiden, what's the radius? So the radius isn't a point, it's a number.
Never mind. I'm gonna go with 30.
How do you find?
I'm at 10.
It's 10. Square root of 100, that's 10. All right. Try C, guys. So take a minute, state the center, state the radius. There's not even a delta math because the one I combined 6.1 and 6.2. I might go ahead and assign it. Honestly, yeah, I make it back and work. All right. Zoe, what's the center? 0, 3, good. Dominic, what's the radius? 1. Any questions on how you figure out the center and the radius? Any questions on how you write the equation given the center and radius? All right, so here's what you're going to do. So that's it for notes today. Now, here is what I'm going to have you guys do next. So for the rest of class, you got a solid 30-ish minutes. All right. I don't have another delta math for you to do. So here's the thing. You'll get to sign another one tomorrow. But here's the thing. If you have makeup delta math, use that time to work on it. If you've done all your delta math and you have nothing else to work on for my class, do pages 3 and 4. That's the optional assignments. If you want to do test corrections, you can see me for the tests because I haven't put them in there yet. Well, it depends on which test you're doing. Are you doing like the Unit 5 one, or are you doing?
Well, I meant, yeah, the one that we just took.
Yeah, I still got those, so you just gotta see me for that.
Okay. I just want to see what I got.
Oh, I can. It's already posted.
Okay. Is it bad? Do you remember?
I don't remember. It was like over a week ago that I created it. So again, guys, use this time wisely. Work on some makeup delta math if you need to. If you don't have any makeup delta math, work on pages 3 and 4 of your packet, and I'll make a link to submit it in Canvas, and that'll give you guys some extra credit.
Yeah, you should like give me your brain. You want this one? Yeah, this one.
I don't know. I don't feel comfortable right now.
So guys, everyone should be working on something. What?
I forgot the rules.
You guys got graphic organizers, right?
I just know am I adding that irrational. I'm just doing the work that I haven't shown everything.